All right, a few things I want to review since we haven't been specifically in this content for just a bit. If I said, what does this function look like? What does it do? Okay, let's do it in pieces. What does just that look like? That was our parent. Okay, good. So most of you did something like this. What does minus 3 change about that original parent function? It brings it down 3. Where does it originally cross the y-axis?
1.
At 1. So where will it cross the y-axis now?
No. Yeah.
Yeah, you got it. You're right. Okay, and then what is this called? The dashed line. The horizontal asymptote. And what would it be for this blue function? Okay, so remember, even though it switches the y-intercept down from 1 to negative 2, the horizontal asymptote is 1 below that with this parent function. Okay, we also did things like put a value out front. What did that change? Like if I stuck 100 out front, how did that change the graph? Steeper.
Yeah.
Also, what did it do? Change the y-intercept too, right?
Yeah.
Okay. How would we make this, instead of going up, how would we make it do something like that?
No. 0.
Okay. So like 0.8 or something, right?
Yeah.
Decay function would make it drop and lose value instead of increase or gain value. All right. And then same thing, we can move the asymptote around with that. How would we move this left or right? Like, let's go back to this original. I want to take this blue one and move it to the right. Let's say 5.
X minus 5.
Good. Okay, so it's up here with the exponent. Move it to the right by 0.5 or something. Or by 5, I mean. Good. Let's do y. Okay, then we got into growth and decay functions. So, like, let's say we're growing 1.5% per year. What would our function look like? And I'm not giving you all the data, just enough to set it up. So this isn't compounding, right? It's just growth. So we did g, if that helps. G of t, actually. What goes here?
1
plus 0.015. Okay. And then if we were decaying, let's do an easy one just to save some time. Actually don't do point. Let's do 25% per year. How would that look? .25 in this case, which is just 0.75. Okay. That's if it's not compounding. We could use this for money if it's not compounding, but that's just not really a thing. Okay, so speaking of compounding, we have 2 formulas for that. We had just regular, monthly, daily, weekly, whatever. What did that look like? Starts with P, 1 plus R over N to the NT. Good. And then continuous. That one was easier to remember, I think. Yeah. Okay, then going back to factor versus rate. If I told you you have a factor of, I don't know, let's say it's like 0.932 to the t. And I want the rate, what would you do? How did we switch between factors and rates? Okay, remember we had to take the difference of this from 1. It was always either, we would subtract 1, which is different from 1. Okay, so how far away is this from 1? And turn it into a percentage. That's all we did. Okay? So if you don't want to do that in your head, do it on your calculator. How far is that number from 1? So 0.68, which is, actually that's not it.
68%.
That would be, but that's not what I wrote. So the 6 is, it's going to be 0.68, right? Yeah. So what percentage is that? Okay. That was what you were quizzed on, for the most part. You were quizzed on right before this SAT review. Speaking of, if you're going to retake, you have till next Friday. So since we had some days off, I'm bumping it to next Friday. If you need that, let me know. Okay, so where we ended up then, we had started talking about logs, and it was things like this. Like if I want 5,000 in my account, but I deposit 3,000 at 5% compounded monthly. How do I solve for t? Do you remember why we were doing logs? That was kind of one of the reasons. So we didn't have a way to get a variable out of the exponent without doing logs. And so instead of just doing guess and check and messing with your calculator for 5 minutes to try to get close, logs are going to allow us to break that t out of the exponent and solve from there. Okay? So what's a log? That's what we're using it for, at least one thing. But what is a log? So at this point, probably grab your notes unless you remember what they say.
Wait, so what was the answer to the one? Oh, the base. Wait, what?
Yep, so we defined it as the inverse of an exponential. It answers the question, what power of the base gives the result? So if you're looking at this problem, what power, which is kind of it's 2 parts, it's 12 times t, but what power of this base gives 5,000? Now we're starting at 3,000, so what would your first step be to solve this if I asked you to solve for t? So think undo to try to get t by itself. What's your first undo? Okay, so 5/3. Now we have some base that we can.
Missed a 0.
Okay, so those cancel. Anyway, what power of that base gives 5/3? That's what we're asking with the log. Okay, let's look at some more stuff. Remember the notation. In fact, if you don't have this in front of you, please pull it out just so you can review this. Remember that C, we use C as whatever result we're talking about. So in exponential form, we're pretty familiar with like b to the x gives you some result. For example, 2 to the third gives you 8, right? So now we have an exponent, a base, and a result. So coming over here, all those pieces are still there, but in different places. So the base we wrote below the word log of the result gives us the exponent. So we could write that, what I just put there, as like log base 2 of 8 is 3. What power of 2 gives 8? That's 3. Okay? Do you remember all this from a week or so, roughly? So that was the connection between these two in terms of notation. And we put some examples down there. Keeping in mind that a log base and a base of an exponent, if they're the same, they cancel each other. So let me write a couple up here and see how you're tracking with it. Like, let's say log base 3 of 30. Sorry. Of 30 is what? Don't shout this out. Just raise your hand when you can give me an approximation without a calculator. Log base 3 of 30. And I'm totally looking for just ballpark, not obviously not exact. Okay. No hands are going up. Here's my suggestion. If you're ever stuck with these, rewrite it in exponential form. How would that look in exponential form? Look at your notes. I think sometimes for some people it's easier to see it written like this when we're asking what the rough value of a log is. So what power of 3 gives 30? What are you going to say? That's what this log is giving you. What are you going to say? What power of 3 gives 30? Yeah, like just over 3, right? 3 to the third is what? 27. So this is approximately, he said 3.2. I'm fine with that for now, okay? So again, how many times itself does it take to get to 30? Let's do another one. So let's keep the number the same. Log base 5 of 30. Raise your hand when you can approximate that, please. Keep writing equals what it should be. Log base 5 of 30, roughly what? Sure, 2 point something, I don't know, 2 point, okay? Let's try one of these harder ones. I'm writing equals because this one actually has a whole number value. If it helps, rewrite it in exponential form. So you're asking what question by evaluating this log? Somebody said. What? Sorry, say it again.
No, you got it.
I just was starting it. I was starting this off.
Oh.
Yeah, good job. Please say it louder.
What'd you say?
Say it without me. She couldn't hear. What power of 1/4 is 64? That's what she said. Good job. How do we make 1/4 be 64? No.
That was sassy.
Alright, well, if we rewrite it in exponential notation, actually, let's pause here and say, well, not say, but remind you that you can break up a fraction to an exponent and take each one to the exponent, okay? What is 1 to something? Like 1 to any power. Alright, so it's really asking this question. 1 over 4 to the x is what? Is 64. So how do we figure that out? You guys remember? How did we get something from the denominator to the numerator? And vice versa. What was it? Alright, so grab your, I think we're going to put this in here and then let's not have this be an issue anymore, okay? Please. Like, no more. No more issues with negative exponents.
I think we wrote this
Well, obviously that didn't help.
Oh. My bad. That was mine.
Yeah, so study these. We're going to use A's and X's and that kind of stuff. Well, actually, probably mostly just A. So if we multiply the same base, what do we do with the powers? We add, okay? So we'll put an example for each one of these. If we did like 3 to the 4th times 3 to the 6th, that's 3 to the 10th. Okay? That's called the product property. Product meaning that we're multiplying. Okay, quotient property. What do we do when we divide? Yeah, say it. We subtract those guys. We'll do an easy one first till we write down the. No, that's like a 6. So we write down the negative exponent property. Okay, and then power to a power. What do we do in that case? So a to the m to the n. Or vice versa, it doesn't matter. You guys remember? Yeah, that's when we multiply these. So m times n. So if we did like 3 to the 4th squared, that's 3 to the 8th. Are these ringing a bell? This is, you learned these in Algebra 1. You're going to need these for our next unit as well. Probably more so, honestly. Alright, so here's why this particular one is why we're here right now, writing this down. So we're going to write this in a simple way, and hopefully the examples will illustrate what it means. So switch position, top and bottom of a fraction, and change the sign of the exponent. Does a negative exponent affect sign of the answer? No, do not change the sign of the result. Can't really overemphasize that. Negative exponents have nothing to do with the sign of the result at all. So let's do a couple examples. 2 to the negative 3. Where is that? Is that top or bottom right now? Top. So move it to the bottom. And change the sign of the exponent. Okay? And then evaluate. What's 1 over 2 to the 3rd? And I want you to pause there and look at that, because it does admittedly look kind of weird that 2 to the negative 3 becomes 1/8. It's not intuitive for most people. So know the rules. And that helps you get through that part that your gut thinks incorrectly. 2 to the negative third, there's no negative sign in our answer. It's just 1/8. Okay? What would this be? 3 to the negative third. Actually, let's do 3 to the negative 2. What's 3 to the negative 2 power? One ninth, yeah. Okay, it goes down to the denominator as 3 squared, so we get 1/9. Okay, we're going to write like 4 or 5 of these, and because they're in the notes section, feel free to put them on your note card. But mainly you just need to know this. What if we do this? 1 over 3 to the negative 2. What if it's already in the denominator? Well, we wrote switch position. So where does it go now? Up. And change the sign. I didn't do that. I said it, but didn't do it. And what's 3 squared? 9. Okay. Okay. Let's do the one that our log was asking about. 1/4 to the negative 3. Remember, with a fraction to a power, you can take the power to both numbers. So next step would be 1 to the negative 3 over 4 to the negative 3. What is 1 to the negative 3? It's just 1. Okay? So this becomes 1 over 4 to the negative 3. Okay, it's in the denominator. Where does it go? Move it up. And change the sign of the exponent to 4 cubed. 4 cubed is what? 64. Okay? So, again, no change in sign of the answer. There's no negative anywhere. It's just 64. Seem okay? All right. You can write this if you want, but I'm just going to link it back. So if I say log base 5 of 1/25th, log base 5 of 1/25th, what is that really asking us? What power of 5 gives 1/25th, right? Well, how do we figure that out? So it's equivalent to this. 5 to the x equals 1/25th. How do I make a 5 go to the denominator? Has to be a negative exponent, right? Not a negative result, but a negative exponent. So it has to be negative 2. Move it down and square it. Seem okay? It's a little weird, I understand that. It's weird. How about the first 3 that we wrote? Are you good on those? Okay. You definitely need to have those like really solid, because when we learn log properties, they're very similar to those, only for logs. Similar, not the same. Okay, so now going back to this. 1 over 4 to the x is 64. What does x have to be? To make that 4 pop up to the numerator and grow, has to be a negative 3. Yeah. All right. That's a quick review of evaluating logs. Now, a lot of times we'll do this on a calculator, but it's good to understand what they mean doing it by hand for sure. So here's some of the ones that we've done. Like what power of 3 gives 40? What power of 6 gives 200? That's what we're answering by writing these log problems. And so we did those before. Let's do a couple more. Go. Okay, I think I might have shown you this one. What is this one? Remember, log base cancels 2 to the, and just gives 8. Which was the whole purpose of, well, one of the whole purposes of learning logs. So I'm going to give you a chance to do these. And you can just, you don't have to put them anywhere official. Just want you to have a chance to look at them. Alright, so this is asking 3 to the what power is 1 over 81. How do we make that 3 dive to the denominator and grow? What's x? X is negative 4. So hi.
Hi. Sorry to interrupt.
Oh, that's okay.
So I need to see if you have any test tickets that were left in your room.
I do not.
Those little tickets, you know?
Yeah, I do.
You do or don't?
I don't have
Okay.
them. I know
Alright,
what
sorry.
you mean. I don't
You
have
gotta-
them.
Yeah. You gotta speak up. Hearing impaired here.
That's okay.
Yeah.
Sorry.
Okay. All right. Thank you.
Yep. So negative 4 makes that, in fact, let's write it this way. 1 over 3 to the 4th. Remember, we switched positions. Okay, how about this one? It's asking this. 7 to the what power gives negative 7? What do you think? I was hoping nobody would say negative 1. Because what is 7 to the negative 1?
7.
You guys, 7 to the 1 is 7.
Yeah.
7 to the negative 1 can't also be 7.
It's negative 7. It's like 0.4.
I'm seriously going to fall on the floor and die right now.
Do not change the sign.
Yeah, so it's 7. Oh my.
You're trying to kill me. Now.
Someone reported.
Not
7.
applicable.
Okay. So it's
Negative.
Because I said it is.
I'm gonna say.
Okay, are you asking for real?
Yes.
I will be happy to explain it if you
Yes.
are. Okay.
None of us are getting
Okay. Okay, in fact, let's go through the whole derivation of y. It's short, but it will help, I think. So if you're not getting this, follow this, please. What is 7 squared?
49.
Okay. What is 7 to the first? I hope we know that one.
7.
Yay. Alright, what did we do on this side to get from 49 to 7?
By 7. Divide by 7.
Okay, 49 divided by 7.
Oh.
Okay, doing it again.
So what's the answer?
We're not there yet, be patient. 7 to the 0. Well, we have to keep doing the pattern.
Yeah.
So it's 1. There's an explanation. If you're talking right now, can you stop? There's an explanation for why something to the 0 is 1. Because as we decrease the power, we're dividing by the base each time. Which, no matter what that base would be, like think about if this base was pi. This would say divided by pi, and I would get to 1. Right? It doesn't matter. It's still 1. Alright, continuing. 7 to the negative 1.
Negative 7.
I have to divide by 7 again.
Negative 7.
1 over 7.
Negative. Positive 1 over 7.
If you divide 1 by 7, you get 1/7. Okay? Everybody good on y? It's 1/7? Okay, so I want you to think about what's going to keep happening.
The next one's gonna get smaller.
1 over, divide by 7. So 1 over 49. 1 over
It's gonna get
243 or whatever it is.
It's gonna get smaller but never get zero.
Will it ever get negative?
No.
Will it ever get negative?
No.
I'm asking everybody.
No.
There's no way I can continue to divide by a positive and make this ever be negative, right? So, is there a value of x that I can plug in to make this happen?
No.
No solution. Okay? You cannot plug in. This is a really important result. So make sure it sinks in. You cannot plug in an exponent and make a number 0 or negative. You cannot do that. Unless the base is negative, but that is not the same case. All right, how about this one?
Log 9.
Those cancel and give 9. Okay? So what power of 5 is 5 to the 9th? Well, okay?
Yeah, I knew that one.
Are we good on this negative thing?
Yes. Are you good? We had to just reteach you.
Oh.
Oh.
We had to reteach you.
I hope I remember it by
I
tomorrow.
hope you did too. I hope you study your notes.
Okay,
You're about to fail.
remember this one? Remember that? We had a V there, not an A, but do you remember this formula? Do you remember that formula, that equation? It's PE to the RT.
Oh, I thought it was a pi sign.
Yeah, they kind of stuck together. Okay, so what if we wanted to solve for T? What's our base? It's E, right?
Why is it not P?
Seriously. Why is it not P? P is not the X. There's
Oh,
no
the
exponent
natural
on the
base.
P.
It's the natural base. Like the continuous.
Okay.
Are we good?
Yes.
Are you guys on this side good? Base is E. So if I said get T out of the exponent, what would your log have to be based on? Like what would be the base of your log? Base E, okay? So thinking through this, we would divide by P. We would have E to the RT. If I want to undo this base, I would need to do log base E of E to the RT, and then those cancel. Are we good on that?
Yes.
Okay, here's the thing. Log base E is so common that we gave it its own name, and it's called natural log. So we won't write it as log base E. Why is it called natural? Where did that come from? Yeah, that's exactly right. E is the natural base, so the log with the base of E is the natural log. And you will see it instead as ln. So if you look at your calculator, right by the 4 button, what does it have? ln. Okay? So when you need to do the log of the base E problem, like our P equals RT, you're doing the natural log rather than going through all the menu and trying to find log base E. You don't need to do it that way. Okay? Now, people sometimes ask, why is it ln and not nl? Why do you think? Yeah, it's trying to emphasize this is a log.
Yeah.
Okay? So that brings up the question, what is the log button on your calculator? If this one is natural log, what is the LOG, just log button? Sorry, what did you say? It is, it's short for that. But it defaults to the base 10 logs. So LOG, if you ever see that in a problem, which you will, not just on your calculator, it's base 10. So base 10 versus base E versus other bases that we have to put in separately. Okay? On your notes, I want this to be quickly referenced. So natural log is ln. And we'll just basically write what I just had. So log base e, log base e, e. That's all we need. And then put log with no base shown is base 10. Okay? And we call this common log. Because our number system is base 10, this is also extremely common as well. Okay? So just know that you can't just use that log button for any log you want. You're actually taking log base 10 of whatever number you're doing. So we'll do some work on this tomorrow. Please go home and let this sink in, this negative exponent business and the